Alright guys, today we're going to look at combining some functions together, and basically what we're doing is nothing here we're doing is new. In fact, some of these you've actually already done before in the past, but what we're going to do instead is combine some exact values with some inverse values later on. But these first couple, they're actually very similar to some problems you've done in the past. What I need to do on these, remember, with inverse function or with composition functions, is you always start with the inside. So if you look on here, the first value I want to do is whatever is on the inside of this here, and that is inverse sine of 5/7. So that answer is going to be an angle, but then I'm taking the secant of that angle. So we've actually done this, again, we have done this before. You don't actually need to evaluate what theta is. You couldn't do that without a calculator in this case. So all we need to do is draw a triangle. So I'm going to draw a triangle. It's going to be a positive value, so that means I'm going to draw it in quadrant 1. So I'm going to draw a triangle in quadrant 1, and the sine of theta is opposite over hypotenuse. So then to find my missing side, I'm going to use the Pythagorean theorem. So that means that x squared is going to be 24. So x equals the square root of 24, which I can actually simplify to 2 times the square root of 6. So that's my missing side. Now that my triangle is all filled in, all I need to do is now look at the outside part of this, and the outside part of my triangle tells me to find the secant of theta. So secant is the ratio of hypotenuse over adjacent. So I just look at my triangle, and it's my hypotenuse over adjacent, which is 7 over 2 root 6, and I'm done. Alright, so we're going to do another one. So again, you have done these before, but it's a little bit different now with the principal values and the negatives. So what I'm going to do is I'm going to draw a triangle, and that triangle has the secant of that angle is going to be -3/2. So if secant is negative, all right, remember arc means the same as inverse. So I could rewrite that question as secant inverse if I wanted to. Secant is like cosine, and if cosine is negative, I draw it in the second quadrant. So I'm going to draw my triangle in the second quadrant, and there's my theta. So my hypotenuse over my adjacent is 3/2. So I can do Pythagorean theorem again to get my missing side. Whoops, thinking ahead there. So I'm going to get that x is going to equal the square root of 5. So there's my missing side. So now all I'm going to do is I'm going to look at that picture. Now that that's all filled in, I found my theta. I want to find cotangent of that theta. So I'm going to do the cotangent. Cotangent is the ratio of my adjacent over my opposite. So my adjacent is -2, and my opposite is root 5. So the hard thing about this one is just remembering which quadrant you need to draw this in for that first principal value. Because again, this is an exact value, not a general solution. Alright, where these get a little bit trickier though is when we move on to exact values. So if you look, these questions are written differently. The questions before, the inverse was on the inside of my function. Now, the inverse is actually on the outside. So what I have to start off with are exact values. So I'm going to start these, again, on the inside. I want to find the sine of 4π/3. So the sine of 4π/3, that's an exact value that we can find. 4π/3, remember, that is an angle. It's a radian value of an angle. 1 pi is all the way around my circle, so 3π/3 is right there, which means 4π/3 is going to be just past that in quadrant 3. So I just drew 4π/3 as an angle. If it's 4π/3, the reference angle is π/3, and π/3 is 60 degrees. So I drew my triangle. I'm going to find this value the same way I've done exact values all year. So the sine is opposite over hypotenuse. So what that means is the answer to my question, the sine of 4π/3 is -√3/2. Once I've found that, I actually have a new question now. And the question I'm trying to find is cosine inverse of negative root 3 over 2. And this is what I've just been doing all along. Okay, but this time I need to draw a new triangle, because if cosine is negative and I'm trying to find the inverse, I have to draw it in quadrant 2 to get my exact principal inverse value. So that means I have an adjacent of root 3, hypotenuse of 2, my missing side is 1. That means that reference angle right there is 30 degrees, or pi over 6. So if that angle is pi over 6, all I need to find now is what that whole angle is. So that's pi minus pi over 6, which gives me a final answer of 5 pi over 6. So these are a little bit trickier, but just remember your order of operations here. You start with the inside, and in this case, the inside is an exact value. Then you have an entirely new question, and you are finding the inverse of one of those exact values you just found. Alright, so we're going to try another one here. We're going to start on the inside, and the inside of my function is telling me to find the cosine of 3 pi over 4. So I'm trying to find the exact value of that ratio. So I'm going to draw the angle 3 pi over 4. Again, it is 4 pi over 4 at that line, which means 3 pi over 4 is going to fall in quadrant 2. That's a 45-degree reference angle, so now I can fill in my triangle, and I can evaluate that answer. I can find the cosine of this triangle, that's my adjacent over hypotenuse. So the answer to the cosine of 3 pi over 4, that gets replaced with negative 1 over root 2, and now I have an entirely new question to answer. And this new question now is sine inverse of negative 1 over root 2. So in order to figure this question out, again, I'm going to redraw a new triangle. If I'm doing an inverse sine of a negative value, I draw it in quadrant 4. That's that principal value. There's my theta that I'm trying to find. I have an opposite over hypotenuse. And if I do Pythagorean theorem, my missing side in this case would be 1, which means that reference angle is 45 degrees. But because it's in quadrant 4, the reference angle is 45 degrees, or pi over 4. But the actual answer going in that negative direction is a negative pi over 4. Alright, the last one we're going to look at, again, it's a little bit tougher just because those are the harder angles to figure out. The inside question is telling me to find an exact value. It wants me to find the tangent of 0 degrees. So it wants me to find the tangent of the angle that is right there on that line. So again, that point is 1, 0. And tangent is sine over cosine, okay, my y over my x, so 0 divided by 1 is 0. Or again, if some of you guys use, if you use this, tangent is, the tangent of 0 degrees is 0. So no matter how you get to that answer is 0. So now I have a new question, and my new question is cosine inverse of 0. So this again is a different question. It's cosine inverse. So I'm not just trying to find the cosine of 0 degrees. So I can't just look here and say, oh, the cosine of 0 is 1. That's not what I'm doing. I'm looking for what angle gives me a cosine value of 1. Inverse values, you look at the inside of the chart. And on the inside of that chart, I've got a 0 at 90 degrees, or in radians, at pi over 2. And those are compositions.